My name is Mr. Popper from Lereko Secondary School in Motero District. I hope you are still doing well because of we are already there. We are almost there towards our final examination. I hope we are preparing very well there at home and at different schools. And then remember, we need to do more and more of practice in order to pass this wonderful subject, mathematical literacy. Now, learners, today I'm going to take you through a very nice topic which is called data handling. Data handling is assessed on both papers, paper 1 and paper 2. So we are going to look at it from its roots and depth today. So learners, let us quickly look at data handling. Now, data handling as a topic and all the processes that are involved in data handling. So let us quickly check what is data. It is very important. Data is a raw information that has been collected without any organization. It is collected, but it is not organized. Now, let us look at data handling processes that we have. In data handling, they said it refers to a process of collecting. Before we do anything with data, we need to collect the raw data as it is, or information. After collecting it, we'll then have to organize it. And then after organizing it, we summarize it, and then we take out what we don't need. After summarizing it, we analyze it. And then after analyzing it, that will be a complete of our data. So it's very important that we collect data, we organize it, we summarize it, we represent it. How do we represent it? In terms of graphs, in terms of your box and whiskers, your pie charts. Those are the ways in which data is represented. Now, data handling, it is a part of statistics. They say it's a branch of mathematics that focuses on processes of data handling. Now, like I said, I'm going to take you through the processes of data handling. The first process that I want us to look at, it is data collection. How do we collect data? It is very important, learners. Now, the data needed is sometimes already available, while at times it needs to be collected. How do we collect it? This data is known as raw data. There are three main methods of collecting data. One, we can collect data by observation. For an example, counting numbers of cars that are at an intersection, or other example of collecting data through observation. It can be maybe you are at a shopping mall, you are required to collect data of males and females who are entering the shop. You don't have to interfere with anyone. You can stand there by the shop and then count how many males are entering, how many females are entering. That's a way of collecting data which is called observation. So data can also be collected in a way of observation. You observe and then you collect information. I saw there was a question that asked about the methods of collecting data in question paper of paper 1 Free State. There was a question whereby the learners were given a data about certain players who are scoring in netball, and then the question was, what method of collecting data was used to get the information about the top goal scorers in this netball tournament? So the answer was very simple because of its observation. You can observe the tournament and then take the scores and then check who's the highest goal scoring player in that particular game, and then you can take information by observing it. And then the second method of collecting data, it is called interview. Asking people their opinions on budget proposal, we can use interview. And then the third one is survey. How long delegates who attended the workshop feel about it? Survey is normally given in a form of a questionnaire whereby you feel yes or no answers. So those are very important methods of collecting data, good people. Grade 12 learners, it's very important to know that we have three methods of collecting data, which is observation, interview, and survey. They are very, very important and they can be assessed. Furthermore, we move in classifying and organizing data. How do we classify data or organize it? Right. One, they say data can be classified in two ways. It is classified in two ways. One, as a categorical data. When we talk about categorical data, it means it's a form of data that we classify data according to categories. Like they say, it's categorical data. Sorry. Data can be observed or not measured. So the examples of categorical data are textures. We can classify data according to categories of textures, of smells, of taste, of gender, eye color, month of the year. Maybe we classify data according to month of the year. The ages, we classify data according to ages. Group shoe sizes, or the country of birth. Maybe we say people who are from this particular country, and then we classify data according to country of birth. And then categorical data can consist of yes or no questions. That's the first way in which we classify that. We classify it as a categorical data. And then the second classification of data, it is called numerical. I think it is very self-explanatory. When we talk of numerical, we talk about numbers. Now, it refers to the data that consists of numerical values, which are numbers. Example includes measurements such as length, height, area, volume, or any other form of measurement. It can be speed, it can be distance, as long as it's a form of measurement. Because of it involves numbers, we refer to it as numerical data. Now, numerical data can be further classified. It simply means we said our data it is classified into two, as categorical and numerical. But numerical can be further classified into discrete or continuous data. Right. Now, what is discrete and what is continuous? And what are the differences between discrete and continuous? What I saw or noticed is that when the question asks learners, in examination, and examiner asks learners, in this form of data that is given, is this data discrete or continuous? Learners will be playing guessing work, of which is not correct. Learners, we should understand the difference between discrete and continuous. As much as we are now, I think, understand the difference between numerical and categorical. Let us look at discrete data and continuous data. Now, discrete, they say it's a set of values that can be counted. For an example, number of children in a family, we can count them, as in like 1, 2, 3, 4, 5, 6, 7. There are 7 children in a family. They can be in a position to be counted. Number of cars parking in a parking lot, we can count that. Number of calculators, we can do that. Number of learners in the class, I can come and count how many learners do we have. So discrete data is a set of values that can be counted. It normally evolves around whole numbers because of when we count, we use whole numbers. And then the second form of data that is under numerical, data can also be continuous under numerical. What is a form of a continuous data? It's a set of data that can be measured. It's a set of data that can be measured. When we say something can be measured, we can talk about example, we measure height with a tape, temperature we use thermometer, it is measured. And then in most cases, sometimes continuous data can have whole numbers because of temperature can be 20 degrees, 25, 26. So continuous data is very important, good people. We say it's a set of data that is measured. Mass, it's measured, and then length, volume. In some instances, you'll find continuous data will behave in decimals because of we are talking about data that is measured. A height of a person can be 12,2, and then also time, because of time has numbers, but we say that a form of a data that time is, we refer to it or we classify it as being continuous data. So I'm going to do an illustration to show you, to remind you on how do we classify data. I'm going to illustrate something for you here. So I'm going to quickly illustrate a very good illustration. We said that when we classify data, we classify it in two ways. Remember, grade 12 learners, I said when we classify data, we classify it in two ways. One, we say as a categorical. We classify data as categorical. According to categories. And then two, we classify it as numerical. We classify it as numerical. And then categorical, I said to you learners, whenever we talk about categorical data, we talk about a form of data that involves categorizing data according to respective or certain properties. Like for example, we refer to a country of birth, a smell, maybe a color. We take colors and then we classify them according to their specific properties. That's what we call categorical data. It evolves about categories. But now numerical, we said that what is important here, it's numbers. We said what is important here is numbers, and then we said it is furthermore classified into two, as it being discrete or continuous. It is further classified as it being discrete or continuous. And then I said again, learners, we should always remember that. It is very important and imperative that each and every time when you say discrete and continuous, we must know the difference between categorical, numerical, discrete, and continuous data. So what is important? Numerical, I said, it's evolve around numbers, and then difference between discrete and continuous. Discrete, what type of numbers are discrete? We said discrete adds a form of data that can be counted. It normally evolves around whole numbers. It's a form of data whereby that it can be counted. For an example, I said that if we count the number of cars that we have in a parking lot, we can be in a position to count that 1, 2, 3, 4, 5, 6, 7, 8. And then with continuous data, I said it's a form of data that can be measured. And then we talk about examples of things that can be measured. We include length, we include mass, we include height. Such an example of data that can be measured. Sometimes continuous data can have decimals. So it is very important, learners, we understand the difference between categorical, numerical, discrete, and continuous data. That's how we classify data. Remember what we learned? We start by collecting it. How do we collect it? We have three methods of collecting data. The first one is by observation. The second one is by interview. The third one, it is also by survey in the form of a questionnaire. So those are methods of collecting data. After data is collected, we now classify it. How do we classify it? As it being categorical or numerical. And then numerical, it is furthermore classified as being discrete. If they have numbers, it's either they are discrete or continuous. Our data set, it's either it's discrete or it is continuous. So it's very important to understand how do we collect and how do we classify data. Right. Right, let us go back to our slides. We said that we now did manage to explain the difference between categorical and numerical, and also discrete and continuous. Now, good people, let us further go to the third process of collecting data. The third process of collecting data, we call it summarizing. Remember, we collected it. After collecting it, we managed to classify it. After classifying it, we are now summarizing it. How do we summarize data? The first method, or the way of summarizing data, we use the measures of central tendency. What are measures of central tendency? A measure of central tendency is a value that provides an indication of a middle or center of the data. They normally go by triple M. It's your mean, it's your median, it's your mode. We refer to them as three measures of central tendency. Let me explain what do they mean. These are three measures of central tendency. The first example of a measure of central tendency, it's a mean. Now learners want to know what is a mean. A mean, it's sum. Immediately it says sum. It means when you add. Again, sum, it's when you add. A sum of data values divided by a number of data values. You add all the data values, and then after that you divide by a number of data values. It means mean, it's sum of data values divided by a number of data values. We'll take a look on few examples of mean after I explain both median and mode. Now let us go to the second measure of central tendency, which is the median. It is a middle value in an ordered set of data. It is very imperative, learners. It is also very important that because of the word ordered, it simply means the middle value in an ordered set of data. It means our data should be in order before we calculate median. Because of hence, I said it's a middle value in ordered set of data. Our data must be in a particular order. Ascending, or sometimes it can be descending. So, but what is important is the middle value must be in an ordered set of data. Mode, which is our last measure of central tendency. Let us look at mode. They say mode are data. It's a data value or values What does it mean by values? It simply means it's a data value or values that occur most frequently in a set of data. It doesn't mean our mode should be 1. Our mode, it's a common number that appears mostly in our data set. They say it's a data value that occurs most frequently in a set of data. So it doesn't mean, or it doesn't necessarily mean we'll always be having a one mode. No, sometimes we can have 2 modes, it's possible. We can even have 3, it's possible. As long as those numbers appear more than any other number. So we can refer to them as our mode in a set of data. That's how we summarize data. And that's the first way of summarizing data. By doing what? By getting measures of central tendency. Now let us quickly go and check few examples on how to work out these 3 measures of central tendency. Now, grade 12 learners, let us quickly look on examples on how to work with measures of central tendency. But the first thing that we have to look at, we classified, remember what we did? The first thing that we collected data, after collecting it, we classify it, and then we organize it, and then after organizing it, we summarize it. Now let us quickly check the example of organizing data. How do we organize data? Here's an example that I managed to prepare for you. It's an example on data that was provided, and in this form of data, because of it doesn't involve about numbers, it's a categorical data. So we are going to work on this categorical data that is given. So it says a sample of female shoppers were asked to classify. We are classifying a perfume as either being sweet, fresh, musky, or citrus. We are classifying perfume as either being sweet, fresh, musky, or citrus according to given categories. Now, use their responses below and answer the following. So these are the responses of the female shoppers that was given to us. So the first shopper say musky, and then musky, fresh, fresh, sweet, musky, musky, citrus, sweet, citrus, musky, sweet, musky, musky, citrus. Now the first question says 1. Complete the frequency table using responses above. So we have to complete the frequency table using responses above. So the first one, it says we have 3 sweet. So if we have 3 sweet, we only have to complete tally. How do you complete tally for sweet? It's 1, 2, 3. Now we have managed to put our tally, which is, because of our frequency, it's 3. So we have 3. And then after getting sweet, how are we going to, because of they said that we have 3 sweet, so it's 1, yes, and then 2, and then 3. Yes, I can only see 3 sweet. Those shoppers who said that the perfume, they classified the perfume as being sweet. Now let's check the shoppers who classified the perfume as being fresh. So fresh, the first shopper here, on the first row, the first shopper who classified the perfume as fresh, it's 1. And then on the second row, we don't have fresh. On the third row, we have fresh. It means we had only 2 customers who classified our perfume as being fresh. 1, 2. And then we write it in a frequency as 2. And then we furthermore move. We check the customers who classified our perfume as being musky. Now, let's go to our first column. Musky, it will be 1, and then it will be 2, and then it will be 3 in the first column. 1, 2, 3, and then it's 4, and then it's 5, and then it's 6, and then it's 7, which was already provided. So how are we going to put a tally of 7? We learned that from grade 5, 6, 7, 8, 9. Just going to say 7. It's 1, 2, 3, 4. Remember at 5, 5, 6, 7. And then we are having 7 as our frequency. And then citrus, they said it's only 1, 2, 3. So if you say 3, here it is. So now let us take a look on the number of customers who took who took place or who participated in this form of a data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It means our total must actually give us 15. 3 customers classified perfume as being sweet, and then 2 classify it as being fresh, and then 7 says it's musky, which is the most, and then they say it's citrus, 3 of them. So if we add, we say 3 plus 2, it's 5, and then 7 plus 3, it's 15. And then it means it corresponds correctly with our total. It simply means we have 15 customers who said who took part in this particular survey. Now, the second question, 2, it says, determine the percentage of shoppers that classified the perfume as musk. Determine the percentage. It means we had 7 shoppers who said the perfume is musk. Out of how many shoppers? Out of 15. And then we multiply it by 100. And then 7 over 15 multiplied by 100. We use our calculator. We say 7 over 15 multiplied by 100. And then we say it's 46.67%. It means the total of shoppers who classify perfume as being musky is 7 over 15. Now we have organized our data in a very correct way, which is in a frequency table. That's how we managed to organize and classify our data. Now that was an example of organizing and classifying data. So the example 2, we are going to look on how to summarize data by using measures of central tendency. Remember on the previous slide I said to you learners, we have 3 measures of central tendency, which are triple M, mean, median, and mode. And then I said to you, what is mean? Mean is the sum of all data values divided by the number of data values. And then we said the median, it's a middle number in an ordered set of data. And then we said that the mode, it is the value of values that occurs most frequently in a set of data. Now, let us go and take an example. Let us go and take a look on example 2, which involves around determining measures of central tendency on each set of data. We are going to determine the measures of central tendency on each set of data. So if we check the first set of data that we are having here, we are having a data that has how many values? Can we firstly check how many values do we have in our first set of data? In our first set of data, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the first thing. We have 11, which is an odd number. We have 11, which is an odd number. So after having 11 values in our set of data, we are quickly going to check, is it arranged either ascending or in descending order? Is it arranged in ascending or descending order? But if I take a look on my set of data learners, you could also check our set of data. The first one, which is set A, it is not arranged in any order. It is not arranged in any order. And remember what I said about median. I said the median, it's a middle value in an ordered set of data. So we can calculate median in a set of data that is not ordered. Can we start by calculating mean in set A? Can we start by calculating mean in set A? I said mean is the sum of all the data values and then divide by number of values. So we are going to look at our data, and then we say the first thing we do, number 1, A, it's mean. How do we calculate mean? We said mean, we add all the values, and then the sum of all the values in the data set divide by number of values in the data set. The sum of all values in the data set. So it's going to be 99 plus 75 plus 72 plus 60 plus 55 plus 111 plus 87 plus 75 plus 59 plus 54 plus 78. And then remember I said we divide it by a number of values in our data set, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we divide it by 11. It's 1, 2, 3, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We divide it by 11. So let us quickly add and then check the sum of all this data set. So it will be 99 plus 75 plus 72 plus 60 plus 55 plus 111 plus 87 plus 75 plus 59 plus 54 plus 78. So the sum of all our data values is 825. It's 825. And then we divide it by 11. And then if we say 825 divided by 11, it will give us 75. What does this mean? It simply means that our set of data, the average, sometimes mean can be referred to as average. It's 75. Our average is 75, which means our mean is 75 in this form of data. Now, the second measure of spread that we are going to look at, it is median. Let us give it a B. And then median. Remember I said median, it's a measure of central tendency. I said median, it's a value, it's a middle value in an ordered set of data. It's a middle value in an ordered set of data. And our data, it is not ordered. So the first thing that we have to do, it is to order our data. Set a data. We have to order it. How are we going to order it? We check. Let us order it in ascending order, from the smallest value to the biggest. The smallest value that we are having here will be 60. Sorry for that. The smallest value will be 60. And then after 60, do we have, it will be 54. If I check correctly, it will be 54. Sorry, learners, for that. And the smallest value here will be 54. Yes, it will be 54. And then after 54, we check the second value. The second smallest will be 55. After 55, it's 54, 55. It's 54. And then we said the next one is 55. And then after 55, we have 59. And then after 59, we'll be having 60. After 60, we'll be having 72. After having 72, it will be followed by 75, and then we have two of those, 75 and 75. After having 75 and 75, we move to 78. After having 78, we are having 87. After 87, we'll be having 99. After 99, we'll be having 111, which is our biggest number. Can we recount how many values we had on our set of data? We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now let's count this one. That we managed to arrange. How many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It simply means we are also having 11 in our arranged set of data. Our data is arranged in ascending order. Remember I said we can't find the median with a data that is not arranged. It's a middle value in an arranged set of data. So we are going to split our data in two halves. We are going to split our data in two halves and get the middle number. So then for us to get the middle number, we are going to say, because of we are having an odd data, it's an odd data. If you check, it involves about 11 is an odd number. So if 11 is an odd number, we are going to have a single median. We are going to have a single median, one median. 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11. So if it's 11, we'll be having 1, 2, 3, 4, 5, and then if we take this 75, we'll be having 1, 2, 3, 4, 5. It means our median is 75 because of we are having 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. It's 5 this side and 5 this side. So our middle value here will be 75. Our middle value will be 75 because of we are having 1, 2, 3, 4, 5, and we are having 1, 2, 3, 4, 5. Our median in an ordered set of data is 75. And then furthermore, we are going to look on other example. I said we have 3 measures of central tendency, which is mean that we managed to calculate that. And then if we recap what is mean, sum of all data values divided by a number of values we have in a data set. And then median, we said it's a middle value in an ordered set of data. And then we go to C, which is mode. We said that mode, whenever we talk about mode, we said it's a value of values that frequently occurs on a set of data. So if you check on set A, which number frequently occurred, or the one that occurred the most, or one that is common. So the common number or the one that occurred the most in this set of data at 75 because of it occurred twice. There is no other number that occurred twice. If we had 2 numbers that occurred twice, maybe 75, 75 and 78, 78, meaning we'll be having 2 modes. It will be, our data will be having 2 modes. It's bimodal. But in this case, we are having only one number that occurs the most, which is 75, and then we say our mode is 75 because of only 75 occurred twice, whereas other numbers occurred only once. So this will be our mode, which is 75. Right, now let us go and quickly look on another form of data. In this case, we'll be looking on the data that is even, not odd. When we say it's even, we talk about the numbers that are divisible by 2. Numbers such as 2, 4, 6, 8, 10, 12. We are going to look at such data that is even, which will be our second example. We are going to calculate measures of central tendency in an even data. Now, the second set of data that we are having, it's even. Let us quickly calculate how many numbers do we have. That's the first thing. Let us check how many numbers do we have on set B. How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We are having 12 numbers. So that data set is even. So the first thing that we do, we calculate our mean, which is A. And then I said, remember, mean is when is the sum of all values divided by a number of values that are in our data set. So sum, we're going to say 147 plus 75 plus 78 plus 30 plus 15 plus 183 plus 111 plus 75 plus 142 plus 27 plus 12 plus 8, and then we divide by number of values do we have in this data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 values in this data set. So if we add quickly, we are going to say 147 plus 75 plus 78 plus 30 plus 15 plus 183 plus 111 plus 75 plus 142 plus 127 plus 12 plus 8, and then it gives us 1000. So 1000 divided by 12. We get our mean value as 1000 divided by 12, and then we get 83, 3. That's our mean value. Let's go to B. It means our average in this case is 8,83,3. So I said B, we need to make sure that we arrange our data in a certain order. If you check, our data is not arranged. So remember we said that the middle value in an ordered set of data. So the smallest value there, it's 8, followed by 12. It's 8, followed by 12. And then after 12, we'll be having 15. And then after 15, we don't have any number in tens, we go to 20s, we check, and then after 15 we go to 20s, and then it's 8, 12, 50, and then we'll be having 27, which will be the next value, and then after 27 we go to 30, after 30 we check the 40s, we don't have, and then we go to the 50s, we don't have, we go to the 60s, we don't have, 70s, and then we have 75, 75, and then we'll be having 75, 75. After having 75, 75, we are having 78. After 78, we are having 111, 111. After 111, we'll be having 142 and 147, 142 and 147. So how many values do we have in this data set B? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it simply means we are short of one value. Let us quickly check. We said that 8 is included, 12 is included, 15 is included, and then 27, it is also included. And then after 27, we're short of 183, which is the highest value. And then so you see the importance, learners, of always verifying your data. After arranging your data, count how many, always do that, count how many values do you have, so that you can be 100% sure that the number that I've arranged are corresponding to the number of the values in my data set. So after having this, we'll then have to arrange this to find the median, the middle value. So since it's even, how are we going to find the middle value? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the half of 12 is 6. 1, 2, 3, 4, 5, 6. And then if we are having 6, it means our median is between these two values. 1, 2, 3, 4. It's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Our median is between 75 and 75. So to get our median, we are going to say 75 plus 75, and then we divide by 2. 75 plus 75 is 150 divided by 2. It will again give us 75. It means the number that is between these two numbers will be 75. So our median is not this 75 or this 75. It's a number which is between these two. And then if you check our data, we don't have a specific middle number, but our middle number is between 75 and 75. So hence we said 75 plus 75 divided by 2, and then it gave us 75. And then the last one that I want us to look at, it is mode, which is the one that is frequently occurring. And then the mode will also be 75 because of it occurs most. Now, learners, I want us to take a look on, to furthermore take a look on, still on summarizing that. Sometimes the examiner, what the examiner will do sometimes, will give you the set of data with a missing values. And then they like such questions, whereby you are given a set of data with missing values. I want us to take a look on few examples using the very same set of data that we are having, and then the mean that we have calculated, to check how can we work it out. Let us quickly look on the set A that we calculated. Let us quickly look on set A that we calculated. Let's say we take the very same set A that we calculated. Remember, we managed to calculate our mean as being 75. So if our mean is 75 as we calculated on set A, So let's say, for an example, we'll be having a missing value there. Given our data, which is 99, 75, and 50. Let's say the missing number here will be 78, for example. Let's say we say this number is missing, and then we are given A instead of 78. It's A in our set of data. 78 is missing, and then we are given A, and then we are required to calculate the value of A given the mean, given our mean. So the examiner will tell you that given the mean is 75, calculate the value of A, which is a value which is that forms a part of our data set. And then you are yes, and then remember that they say you are given the mean. Our mean is given as 75. Now the examiner wants you to calculate the value of A with the mean given. So if the mean is given, we are required to calculate the value of A. How are we going to calculate the value of A? So I said we are assuming, learners, that the value of A is not given. We are assuming that we don't have the value of A. And then the examiner wants us to calculate the value of A given the mean. In this case, we have the mean. Remember what I said, that the paper said to you that whenever we calculate the mean is sum of all the data values divided by data values that are in a data set. So in our data set, we have 11 data values. So let us add them, including A. We said that mean is equals to, sorry for that. We said that mean is equals to, we add them all, it's 99 plus 75 plus 72 plus 60 plus 55 plus 111 plus 87 plus 75 plus 59 plus 54. Remember, I said we don't have 78. We are looking for it. And then we said that we labeled it as A. And then we divide all our data set by 11 because we have 11 data values in our data set. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, including unknown A. But remember, we cannot have two unknowns. We were given mean. And then the examiner said to us, our mean is 75. So if the mean is equals to 75, we are going to say our mean is equals to 75, and then we add all our values. So if we add all our values, we'll be definitely having, if we have to add all our values, we are going to have we are adding all our values. $747. We are having 747 after adding all our values, and then plus A divided by 11. So if this is the case, plus it says plus A divided by 11. And then remember, we are looking for A. So we say this one multiply by that, this one multiply by that. And then if that's the case, 1 multiplied by that, it will be 447 plus A is equals to 75 multiplied by 11. And then if you multiply 75 by 11, it gives you 825. And then after saying that, we say A is equals to 825 subtract 747. And then the value of A will be 825 minus 747. The value of A will be 78. Remember that? It means it's correct because I said to you, we are assuming that the 78 was not here. So we managed to get the value of 78 in that way. We managed to get the value of 78. So it's very important then, as each and every time when we are given this form of data, we know that it is not always the case where we'll be required to calculate mean. Sometimes we'll be having a missing value. And then if we are having a missing value and then we are required to calculate it, but the mean in this case was provided, it is very easy for us. We add all the values that we have. The concept of mean, adding all the values that are in the data set and divide by number of values that are in the data set. And then you do that, and then remember where I put 75, it is in place of mean because of my mean is equals to 75. And then after doing that, I say 1 multiplied by that, 75 multiplied by 11, it gave me 825. And then after getting 825, I say 825 minus 747, and then it gave me my value at 78, which is 100% correct. Even with median, it is still the same. Sometimes median can be given, and then you'll be required to calculate it. And then, let's say for an example, we are given an ordered set of data, which is odd, and then this is the sizes of learners in our school. We are having 6, and then 6, 7, 8, 9, so we took a sample of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 learners, and then we saw that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if you are given a number of learners as 10, and then here they will say this learner and then this learner is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we don't have a size of this particular learner. We don't have a size of this particular learner. So for us to get the size of this particular learner, they say it's A. And then we are required to get the size of that particular learner. So for us to get the size of that particular learner, how much was the size of that particular learner? What must we do? The first thing that we do, we are given that the median, the examiner gave us that the median at 7,5. The median, our median at 7,5. Our median is 7,5. It was given that our median is 7,5. So if our median is given as 7,5, we have to calculate the missing value, the size of this learner A. So for us to calculate the size of learner A, we say, okay, remember median. I was told that whenever I'm having an even data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This data is even. It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My median is between 8 and 8. So median is equals to 8 plus 8 divided by 2. This is how to find the median, remember. But the problem is we don't have A. We don't know how much is A. So for us to do that, we say, okay, what the median is given as 7,5. 7,5 is equals to A plus 8 divided by 2. And then we put 1 here, remember, and then we apply cross multiplication. 1 multiplied by A plus 8. It's A plus 8 is equals to 7,5 multiplied by 2. It will give us 15. For us to get the value of A, we say A is equals to 15 minus 8. It means the size of that learner A will be equals to 7. So that's how we manage to get the value 7. So learners, is very important that we are not always going to be told to calculate mean or median. Sometimes we'll be given mean or median, and then we'll be required to calculate the missing value in a set of data. So it is very important that you work throughout, and then you make yourself set of data that are arranged, and then you work it out. You try few examples and see if you are in a position to answer such questions. And then next time when we meet, we'll do quartiles. After doing quartiles, and then we'll do the representation of data. I hope you enjoyed the lesson, and then you managed to learn One and few things regarding data. If we quickly recap on what we did with data handling, the first thing that we did collection of data, methods of collecting data, which I managed to tell you what are the methods of collecting data, and classification and organization of data. And then I taught learners how to classify data. It's very important to understand the differences between categorical, numerical, continuous, and discrete data. And then lastly, I did summarizing of data, on which I only dealt with measures of central tendency. So I hope next time when we meet, we'll be in a position to work with the other aspects, which are quartiles and how do we represent our data. Thank you very much.